Features of exponential functions. What word is inside exponential functions? Yes, exponent. Exponents are going to be important for these kind of functions. So important that my exponent is going to be x. Something like b to the x. A number to the power of x. Okay. We're going to do a little warm up. I'm going to draw you a table. I want you to talk to the person next to you about which function is growing the fastest. Oh. So this is x. I'm going to do 1, 0, 1, 2, 3, 4. F of x, g of x, and h of x. So we got 3 different functions. Do 1, 4, 7, 10, and 13. G of x would be 1, 2, 4, 8, and 16. H of x, 1, 3, 9, 27, and 81. Which is going fastest? And justify. And if you got to that point, maybe write down what functions these are. Which one do you think, Quinzel? What's happening in f of x? If I go from 1, yeah, 1 to 4, what am I doing? 4 to 7? How many? 7 to 10? Yeah, okay, what about 1 to 2? You're good. You can think about it. You can talk to Desi about it too. I think Desi already got some ideas. I think Desi's got some. Yeah. How do I go from 8 to 16? No, solo for advanced music. No, this year. What about last year? Your advanced? Wow. I think it's. Were you guys close? Okay, Desi's group, what did you guys think? Okay, h of x? No? What did you think? Oh. Declan thinks h of x. Beatrice thinks h of x. Benj's group, what did you guys think? Yup. H of x. Kian, what did you think? Yup. H of x. What is happening in h of x? Multiply by 3. What about g of x? What about f of x? Adding by 3. Yes. What type of function is f of x? Is it linear, quadratic, cubic, squared root? What type of function is it? What? It's like you could graph it. You could graph it. Do you want to talk to it? Yeah, go ahead. You're good. Declan, you told me what it was. What type of function is it? Just f of x. Oh, okay. Is it linear, quadratic, cubic, squared root? F of x. Linear. Yes, it's linear. It is a straight line. The equation for this is actually, so we added 3, so it's 3x plus 1. That is the linear function for this. Okay? This is linear. Okay, 1 times 3 is 3, plus 1 is 4. 2 times 3 is 6, plus 1 is 7. So that's a linear function. Linear, or linear equation. Now, the other two you guys don't know yet, which is really fine. G of x, we said it was multiplied by 2 each time, right? So it's 2 to the x. This is a exponential equation. Potential. H of x. What would h of x be? You got it, Desi. Say it again. 3 to the x. Yes, 3 to the x. This is also an exponential. Okay, I want you to all graph h of x for me. So, graph h of x. What shape do we think it's going to be? Okay, I heard curvy. Declan, do you still agree that should be a straight line? No? Okay. I want you to graph it. See what type of graph you get. X, we have h of x. You don't have to write this graph again. You have it up above. 1, 2, 3. Nope. Do you want to add some points? Okay, you graph it. I'm sorry. Take your time. Okay, my first point right here is 0, 1. Now, if I keep going, my next point is about 1, 3. Then I have 2, 9. Okay, I'm gonna keep going. We have more numbers. 3 and 4, it just keeps going up and up and up. Kind of in that direction. A little curvy. What about negative? Can I have negative 1 as my x value? Yeah. So what is 3 to the negative 1? Remember we did exponent powers? If I had a to the negative n, it's also written as 1 over a to the n. Yeah. Jade, what did you say? Not 3 over 1. Yeah, 1 over 3 to the power to 1. So 1/3. So now negative 2. Can I keep going? What is 3 to the negative 2? Yeah. 3 to the 2 so equals 1 over 9. Declan, can you plot those 2 points for me? Up there? Yeah, do you want to do it on here with this? Okay. Yeah, 2 we just added. That one and that one. Yeah. I erase this. Declan, could I keep going with like negative 3 as my x value, like negative 4, yeah, or negative 100? Can you continue the math on what that would look like? Wait, can you connect all of them? I love that you never touch the line. That's great. Yeah. Okay, I would definitely draw that as well. Somewhat what Declan had. Going down, down, down. I'm gonna go forever. Ooh. Without touching the x-axis. We're graphing h of x right now. Yeah. This is an exponential function. What is the domain and range of this function? Desi, what's my domain? Domain? Yeah. Talking about x values.
Oh, x values. Mm-hmm. Infinite. No?
Yeah.
Infinite negative.
Yes. So all real numbers or negative infinity to infinity. Yep. Or what about my range? Can you tell me what my range is? So I'm talking about y's. What, Jade? Nope, never touches it. It's almost as if there was an asymptote right here, or there is an asymptote right here. Ooh. Right at the x-axis. There is an asymptote. It cannot cross this asymptote. So I have an asymptote at the x-axis. So Jade, what would my range be? Just greater than 0? Yep, you're right. Yeah.
Are the points 0, 1, 1, 3, and 2, 9? Are those the points that we were plotting, or all of them?
We're plotting all of them. So it's also 2 1/9 and 1/3.
How did you get 3 from 3, -2 to 1, 9?
3 -2 to, okay, so remember our property of a over negative n to the negative n also equals 1 over a to the n?
Yeah.
From, yeah, it's that same thing. Yeah, yeah. Domain is all real numbers, or you can say in negative infinity to infinity. Either one. That's an or right there. I know it doesn't look like an or, but it is.
That's a 4.
Or. Either one. Okay, that, you just graphed an exponential function. We're going to write this more as a parent function or a base function. Do you guys have this? Good? Yeah, okay. Let's define exponential function first. Definition. Okay. An exponential function is written like f of x equals a times b to the x, where b does not equal 1 and a does not equal 0, and b is greater than 0. Ooh. So when we graph this function, call it b equals y equals bx, our domain is all real numbers. Our range, we said before, was y is greater than 0. Where was our asymptote?
0. Oh.
When y or x equals 0.
Then y equals 0.
Yes, y equals 0, or you're going to say x-axis. What was our y-intercept on our graph above? Yeah, the h of x. I'm going to scroll up for a second. When do we cross the y-axis? At what point?
The y, is that what you said?
Yep. When do we cross it?
Oh,
0. Yep, 0, 1. And if you saw over here in our g of x, it was also 0, 1. It's going to be the same y-intercept. So 0, 1. So whenever you have this graph, it's going to have this point 0, 1. If we just have b by itself, and then shoot up like that, more curving. But we have a asymptote right at the x-axis. Now with any type of graphing, there's going to be some transformations. We did a lot of it with the radicals in our last unit. Now we're doing transformations of exponential functions as well. So remember plus or minus k at the end of all of our functions?
Sorry, say that one more time.
It's okay. We're going to go over it in a second. We're going to see it visually. I'm waiting for you all just to write down. Remember transformations, Beatrice? When we moved things like up and down, left to right? Yep, okay. Do the same thing here. I'm going to need 4 volunteers, though, to come up. I'm sorry. Did I also mention that you get candy if you volunteer? Okay. I got one. Thank you. Okay, 2. I need 2 more. Okay, got 3. No, first hour was jumping on this opportunity. I need a 4th.
Yeah, well, actually, no, I don't want candy.
No, it's super easy.
Jay's the fourth person.
Okay, come on up.
Bro volunteered you. So, how many people? All of us?
I need, yeah, all 4. Where to play?
Is that silly? Do you think that's a waste of money?
What?
Like in college, you just get a big whiteboard and then use it to take notes.
I mean, there's probably gonna be spaces where you can have giant whiteboards, but also I just wrote on the windows in college. Because most windows are dry erase. Okay, my 4 volunteers. Go up to the board, to the computer.
Oh, okay.
Oh, that's so cool.
Can you up first? Can you move B for me?
Oh shit.
Yeah,
Move B for me. Okay. You moved it.
I'll go down.
B. B's right
What?
here.
Sorry, B. You're saying B.
How much?
As much as you want. Any direction.
Oh,
A 10.
that's boring.
Wait.
Yeah.
It like
Deeper.
The line's getting smaller.
straighter, yeah.
Yeah, you're just getting a little steeper. Can you put it back on 3 for me?
3.
Oh, I hate this one.
Oh,
That's
Oh my
all.
goodness.
That's too
Wait, can I
many.
just? Oh my god,
Oh.
Wait, use the pen. Oh my.
Use the pen.
Click.
Move K
Yeah, okay.
to where? Just any?
What happens if we move it?
Down.
Yeah, what if we move it up to a positive number? What happens?
Goes up.
Yes. Remember, K and this is our asymptote. So it's moving back.
Oh.
We're shifting up, or we're shifting down. Can you put it back at 0?
Oh jeez. No, I got it. Hold on my finger. Guys, I got it. Stop.
Told you, bro.
Oh,
Okay, who's next?
Desi's next.
okay.
Fifth
I guess.
I'm volunteering, guys.
A. Okay. Oh.
Like, slowly.
Oh.
Oh, it's flipping it.
Yeah, so when
Oh.
you ignite
Isn't that called?
Translation or
flip.
something?
Yeah.
Translation?
reflection.
Yeah.
Over what axis?
The
X.
X.
Okay, can you put it back
I
at
got you. First try.
Put it back at 1. Oh,
1, not 0.
yeah, 1.
One.
Oh, 1. Oh, first try.
No.
Okay. Last one.
So you can go first try.
What a baby.
Sorry, I just have to throw it.
This one's what's it called? This way. Yeah. Oh, no. No, he's right.
When
Oh, it is.
Wait, so what is it doing?
Yeah.
Oh wait, how is
So-
H different from B?
H is
It got wider.
Here, move B now.
I think Jax is just the reverse of that.
Oh, it's just steeper.
Yeah, it's just steeper. H
to the
is
slope.
moving left
Changing
over.
the slope.
So can you put B back at like straight? That's what it was.
Let's see. First try.
And then can you move H to 3?
H.
H to 3.
H.
Oh, that's
Yo, bro. What is?
first try.
Okay,
Ooh.
so this point was 0, 1, right?
Yep.
When we moved it over to now it's 0, 3. So moving left or moving right? Perfect. Thank you.
Where's your candy?
Got that candy.
Yeah.
Is there actually?
Take care. Take care.
Oh.
Kit Kat.
Thank you, Miss Sweet.
No,
Thank you.
Okay, I was gonna offer you window. Okay.
Oh, that's okay.
I think the answer is
Let me answer the next
The
question.
answer. I love. We should do that.
This is
Also.
anything
Oh.
Sorry guys, I prepared the budget.
Okay.
I prepared the budget.
Okay, thank you all for coming up. Let's write this in our notes now. So, transformations. Transformations. We have f of x equals a times b. I'm just going to split this out so we can write. To the x minus h plus k. So, what we found out, when k is positive, we're going up. When it's negative, we're moving down a graph.
Wait, is plus K part of that? Oh.
Yes. I'm just writing it split out a little bit so I can write. I'll write it a little closer. Plus k. K.
So K is halfway down?
Yes. H. If H is yes, negative, we are moving right. If it's positive, we're moving left. A. This was a reflection. If it's negative, equals reflection. Who was A? Desi? Yeah. What line did it reflect over again?
X-axis.
Yes, x-axis. Okay, I know how much you all love graphing, but we're not going to do any more graphing. That is it. No. In about 2 more chapters, we're graphing the inverse of this. Okay. But right now, we are going, actually, I think I can steal it from these guys. Sorry. I'll go back in a second. Oh, wait, no, I can't. This is first hour. I was going to steal it from them, but I can't do that. Okay. We're going to do a word problem. We're all going to do it together.
Wait, what's B then? What's B again?
B was just like steepness, but you, yeah. Okay, let's see if I can take this. Can I do this? Let's see. I'm going to take it. Ooh. Copy. Okay. We got all the notes? Do I need to go back? Okay. File, edit, paste. Oh, perfect. I don't have to write more. Okay. Population of a large city was about 4.6 million in the year 2020. It grows at a rate of 1.3% for the next 4 years. I would definitely be writing this down. What exponential function models the population of the city over the 4-year period?
4 million.
Yeah, million. 4.6 million. Yes.
It's crazy there's less than 1 million people that live in Alaska, but it's the biggest city.
No, seriously. There's 8 million people just in New York City
Oh my
alone.
gosh, that's awful. Sorry, that sounds awful.
Pressure.
It's okay, I don't live there.
I would want to go to New York City.
To visit.
Yes.
Yeah. I mean,
Just imagine the traffic. Just imagine the traffic on like a busy day.
what? Just in New York City alone, which is just like a little tiny like borough. It's like 5 miles. It's just Manhattan.
The rent there is expensive.
Oh yeah, it's very expensive. But they also have like 100-floor buildings, so it's like they got room kind of, but it's super expensive.
I would totally go there like Christmas.
It's louder, right? Like the homeless people.
Christmas time is beautiful. Yes.
Dude, don't they always show New York during Christmas?
Yes, New York during Christmas is great.
Oh, hello.
Okay, exponential function. What is the equation of an exponential function, Kian? F of x equals a times b to the x. Yes. We're just going to stick with that for right now. Okay. Because we're not graphing it right now. We're just doing a word problem. I would add like the h and k if I'm graphing it. Okay. This problem, we're going to model population. So we're going to use P for population. and it's over a time period. Okay, so P of T, this equals the population,
Over time.
yes, after T years.
How much do we know?
T years. We're going to use T. T years, because for time. Okay, our A in this problem, and every other problem, would be our initial value. So this is the start population. So when T equals 0, so what is our start population? Yes, 4.6. What's our unit?
1.3%.
What's my unit for 4.6?
4 years?
A year.
How many people? 4.6. Is it one person? Is it 4
Million.
million? Yes. Million. B is our growth factor. We're going to talk more about growth factor in a little bit. Growth factor.
What is B at?
Is this just for number 1 or something for A, right?
This is just for A, yeah. We're just getting our equation.
What does B do again?
Growth factor. So this is, I'm going to say it 1 second. This is how much the quantity changes each step. So how much we change each time. So how much are we increasing each time? Yes. So for all of our growth factors, it's 1 plus our rate, which is a decimal. So you told me it's 1 plus, oh, how do I write 1.3 as a decimal?
Why is decimal?
1.3% as a decimal. 1, 3, yeah. I just shifted over 2 decimal places. So shift over 1, 2. That's it. And I'm adding it to 1 because that's like 100%. I'm taking 100% of the population and then adding another 1.3% the next year and every year to the future. So T is our years. That's it. Years. And we're trying to do 4 years, right? Okay. I need some more room. Okay, I'm going to write the formula down here. So I have PT equals what?
4.6.
Yeah. And then Declan, what is my growth factor? What is all of B if I add these two together?
2.013R.
This is a 1. 1,
Oh, I thought you 1.0.
yes, 1, 3. And I got T for time. T is how many years? So we're looking at 4 years.
What is the 0.013?
That was like 100% of our first year. And then each year from there we go 1.3%. So 1.3%, write it as a decimal, is 0.013. Yeah. So if I plug in 4 here, Dizzy, what do you get if you put it in your calculator? I'm just making, instead of percentage, I want it as a decimal because I don't want 100% or 113%. I want to write it as a decimal. Everyone should have a calculator. Let's all try it. What do we get when we put it in the calculator?
About 4.84. So 4.6 times 1.013.
Yep. And then we raise it to the power of what? I would put parentheses instead of multiplication.
What is the?
It's a little
What is that? Big.
one.
1 plus 1.
I think. And then raise and power of 1. Second. Down. Oh, it's because we're on the other ones.
Oh, that's a 4. I thought it's
And
3.
then equal enter. Yeah. Wait. Now, raise to a power.
You're welcome. If I round this to the nearest tenth, what do I get?
4.80.
4.8.
Oh, we were on it.
I just chose to round it now. What's my unit?
But
Yes, 4.8 million people. Did we all get it with the calculators on how to raise to a power? Yes, 4.8 million. Now, part B says if the population continues to grow at the same rate, what will the population be in 2050? Yes, so I'm changing our t. So I still have my same equation.
oh no.
Yes, why are we doing 30 years? Yeah, or subtraction. 2050 divided by 2020 equals 30 years. So now P of 30. Try that in your calculators, see what you get. So we're changing it, instead of going just 4 years, we're going to go all the way to 2050 and predict the future. Yeah. Say it again? Change, yeah.
Wait, here.
No. Lucy rounded it, so we didn't have to do 6.7. We did 6.8
Oh yeah.
million. Okay, how do we feel about that problem? Pretty easy? Sort of? We're gonna round to the nearest tenth. Yeah. Okay. You guys all just wrote down exponential growth equations. We're gonna write this down as our definitions. So, defining this. Exponential growth model. We had, say, A of t for a general one.
Is this a new one?
No, it's not another problem. This is just like the general formula for it. So A of t equals A times 1 plus R to t. T was years, right? year, or a time period. But tomorrow-ish, we're going to talk a lot about years. This entire portion right here is called the growth factor. Just R by itself is the growth rate. So in the last one, we had a positive growth rate. A was just our initial value. Now, if I have a growth model, can I also have the opposite of that? Okay, receding. Can we think of any other words to call it? No. Growth. What's the opposite of growth? If a flower grows, when it ends its life, it also dies, also called decaying. Yes. I mean, the all good words, like receding, dying, it's just decaying. So, decay. Decay model. The only thing different is that inside it's y. 1 minus r. So this entire portion is our decay factor. And this is our decay rate. That's it. So in the last one, the population was increasing, so we had a growth, but population was decreasing, we could have been a decay. Next, we're going to do groups, and we're going to do a problem on the board. Okay? Yeah. Yeah. What? Oh. Maybe it's the last 5 minutes. This will be a break. We're gonna have Pi Day on Thursday. Yeah. It's Thursday. Yes. 2 days. Okay, wait. Groups. Because we don't have so much time. Do you want to just count? Okay. Let's do 3. Yes. 1.
Oh, 1.
We're gonna
3.
You want to start from 3? Okay, 3.
2.
Oh, 2.
You do 2 either way.
Okay, find your group on the board. And I'll put the problem. I'm gonna hand you the problem.
Don't worry, guys. I got you, guys.
Hey, who's ones? Hey, hey.
The board. It's gonna help you with this problem. Who's my ones? You have 1?
We have a one.
Choose in the back.
Got marker right here.
Thinking about purchase. This purchase for 58,000.
It's like 4% each year. So we know the bow font.
Oh, decrease. Okay. So we're gonna be using the decay rate model, guys.
$1,000.
Yep. That would be our initial value.
What?
Yeah. 58,000 will be the initial value.
The start value, right?
Yeah. Yep. Start there.
So the value of the boat. Oh, so we should do B or value.
We need to throw the 12%.